Okay, we're going to look at some geometric series here. Um, there's three numbers here in this geometric series, 27 minus 9 plus 3. That's a geometric sequence there. But they want you to find out what the sum of the first 8 of these terms be of this geometric series. So, well, write down. The thing is, you're looking for S8, the sum of 8 terms in a geometric series. And you know that the first term is 27. If you want to find what's called the common ratio, all you have to do is divide two consecutive terms. You can go minus 9 over 27. That reduces to minus 1 over 3, or 3 over minus 9. It's minus 1 over 3. That's the common ratio. And you know what n is in this problem? You're looking for 8. The sum of 8, n equals 8. Well, you write down your formula. The sum of any terms is a times 1 minus r to the n over 1 minus r. This is a good form when you've got fractions, because when you subtract the fractions, it's a little easier to work out. But actually, you're using a calculator, so it doesn't much matter. The sum of 8 terms, a is 27, r is minus 1 over 3. And all you do, another r is minus 1 over 3, just put it in exactly, and n is 8. Put it in exactly the same way as you see it. Press equals on your calculator, and you'll get 20 and a quarter, 20,25. And that's your answer. Here's the next example. This one, you've got the sum of n terms of a geometric progression is equal to 23 and a quarter. Okay, so all of these add up. We don't know how many add, but they add up to 23 and a quarter. So first, write down all the stuff you've got. The sum of these as n terms is 23 and a quarter. The first term is 3 over 4. You know that. And you can get r equals 2. You can get that just by taking two consecutive terms and dividing. 3 divided by 3 halves is equal to 2. You could try it in your calculator or work the fractions out. Now you've got r. You could go 3 halves divided by 3 quarters, and it equals 2. You've got r, you've got a, you've got the sum of n terms, Sn. All you do, write down the formula. Instead of Sn, put in 23 and a quarter. Instead of a, put in 3 quarters. Instead of r, put in 2. Okay, now we're going to do a little bit of work. We won't just put this into our calculator. 2 minus 1 is 1. That's pretty easy. You've got a 3 over 4 and a 93 over 4. Now, the thing you do to both sides to make this 3 over 4 go away is you turn it upside down, make it 4 over 3, and multiply both sides by it. Well, the 4 over 3 will cancel with the 3 over 4, and you'll just end up with 2n minus 1, 2 to the n minus 1. But the 93 over 4 times 4 over 3, the 4's will cancel. You'll get 93 divided by 3, and that's 31. You add 1 to both sides, you get 32. 32 is really 2 to the 5th power. And now you can see n equals 5. There must be 5 terms in this geometric progression. Well, that's how it works. That was pretty quick, so you might have to play it over again and look at the question a little bit carefully. Here's the last example we're going to look at. The first term of a geometric series is 3, and the last term is 48. The sum of all the terms is 93. Determine the number of terms in this series. Okay, well, write down what you know. You know the first term is 3. You know that the last term, Tn, is 48, but you don't know what n is. And you just so n is your big question mark here. Well, the first thing is you write down the formula for the nth term. You know the last term, Tn, is 48. A is 3, so you write that down. Times r to the n minus 1. You've got that formula. Now, there's a bit of a trick here. It might be a little bit hard to see. When you see r to the n minus 1, it really means r to the n times r to the minus 1. And r to the minus 1 is 1 over r. So this whole n to the minus 1 is r to the n over r. Well, now, if that's true, you could multiply both sides by r, and the r would come over here, you see, like this. You divide both sides by 3. 48 divided by 3 is 16. But when you multiply by r, there it's come. It's 16r. and you're just left with the r to the n by itself. So think you've got r to the n over r equals 16. Here we just divided by 3 to make 16. 48 divided by 3 is 16. But now think of it as being r to the n over r. Now we multiply both sides by r. That's why we have 16r equals r to the n. Okay, we need that. We've got some, because we're going to use it in the next part. We can write down our sum formula. We know that the sum is 93. We know that a is 3, but we know r to the n is 16r. So we can rub out r to the n and put 16r. Well, that's pretty interesting. Now let's just take a look what we got here. We've got r minus 1 here. We multiply both sides by it. It cancels. We go 3 times 16r is 18r. 3 times minus 1 is minus 3. 93r. 93 times minus 1 is minus 93. We add 93. We subtract 48r. We get 45r equals 90. We divide both sides by 45 and we get r equals 2. Ooh, that was a bit tricky. Just go through it really carefully. It's really just substitution. We just substitute in all the things we know. Sn, r to the n, a, and then you solve for r, and we got r is 2. Now we go back here, and instead of r to the n equals 16r, we've got 2 to the n equals 16 times r, which is 2. Well, 2 to the n equals 32. 32 is 2 to the 5th. So, hey, again, n equals 5. There must be 5 terms in this series. And that's it. That was a little bit quick, but you can play this video again and again and just stop it, think about it, and hopefully it'll help you. I hope it helps you. Okay.